This episode of the Math Together show is brought to you by Exemplars, rich and engaging K-12 math performance tasks. Hi, and welcome to the Math Together show, where thoughtful math educators gather and learn together. I'm Molly Vokey.
I'm Sue Looney.
I'm Heidi Subnani. Thank you, everyone, for joining us this evening. We're so thankful that you are here. And we are really excited to speak with our guests today. Berkeley Everett and Janene Ward are here, and we're going to be speaking about how might math facts obscure what students really know. And I think this is such a critical topic in regular years, but then as we think about this year and what our students and teachers have been going through, I think getting at that real learning is going to be important.
Yes.
Absolutely.
Yes, absolutely. So if you are watching, please say hello, hit like, tell everyone that you're watching. We'd love to know where you're from. And Berkeley and Janene are going to really love it if you chime into the conversation today. So please feel free to do that. And they are offering 2 free workshops in our raffle today. So you can, let me see, I got to put that up. You can win a How to Use Math Flips to Build Fluency workshop. And if you put a comment in, you will be entered into the raffle. So please comment.
Excellent.
Yeah. Sue, are you going to?
Yep.
Oh, sorry, you're just waiting. Sorry.
Yep. So if you want to spend some time with us, we are Looney Math Consulting, and we work with teachers to help bring powerful mathematics to your schools and to celebrate the joy of mathematics for all learners. So you can find us at looneymath.com, as well as several free resources are available there for you. And we're currently looking for partners. So if you're interested in partnering, let us know. You can join the mailing list. That's a super easy thing to do, and you'll be kept up to date, and free things arrive in your mailbox a couple times a month. So you can do that right now. You just text Looney to 22828.
Hey.
Excellent. So I have the pleasure of introducing our guests today. So first up is Berkeley Everett. He's the creator of Math Flips and the Math Visuals WordPress, or his website, berkeleyeverett.com. He facilitates professional development for the UCLA Mathematics Project, develops digital manipulatives for Dragonbox, and speaks internationally on math, visuals, and fluency. His new website, berkeleyeverett.com, helps you visualize the math you teach. And Janene Ward has been an educator for 25 years and is the wife to a super hot husband, Ian, and mom to 2 amazing kids, Olivia and Ian James. Janene is passionate about children's mathematical thinking and redefining who gets to be and what it means to be a mathematician. She has always been curious about what inspires teachers to change and sustain changes to their practice. So we're so thankful that they are joining us from sunny California today.
Let's bring them in. Yay!
Hey, good to see you.
Welcome,
Hi.
Welcome. We're so happy that you're here. How do you have 25 years of experience? You look 11.
Thank you.
Yeah, that doesn't seem very fair.
Yeah, the white hairs, they're in there.
Oh, okay.
Turned everyone.
And I want to say I did not get to hear Janene's bio until just now, and I didn't know that we were allowed to pander in our bios.
Yeah.
I think I want to rewrite.
Absolutely.
That's right. You're gonna have to rewrite yours. That's right.
Yes. But
Well,
see, my husband he's not here to hear it, so we'll have to watch it and play back.
Yes, that's right.
Yes,
Perfect.
absolutely. I mean, then it puts everyone on notice. Like, yeah.
Perfect. So we always like to start with what is your why, because that helps our viewers to get to know you, and we always enjoy learning about your road to where you are today. So what is your why?
Yeah, so I can start, and for me, part of it was in my intro for sure, but kind of going back, it's, math should, can, must, and does make sense. And I think for me growing up, that was not the case. I made it through math. I was a really good memorizer. I had my sticker book, or it was my math workbook in 3rd grade. I had all the stickers for all the times tests that I passed, front and back cover, inside and outside. And when I got into high school, things just started to fall apart. By the time I was a senior taking calculus, I would go to sleep with my notebook underneath of my pillow, hoping that I would be able to pass the test that was going to be the next day. And it wasn't until my sophomore year in college with Professor Lar, and he said, math is simply about patterns and relationships. And I was like, how am I 20 years old and now hearing that math is about patterns and relationships? And from there, it kind of just sparked this this curiosity, this love, this excitement, this commitment to making sure that math makes sense for all of our students.
Yes. Excellent.
Love that. Love that.
Yeah, and I'll add on all of that, and it's this place of so much potential joy. And if we're gonna ask kids to spend, about 12 years of their education engaging in this activity, it better be fun and enjoyable most of the time. And I feel like it's such a beautiful place for us to get to know each other, to get to know different perspectives, to build insight and surprise and all of these emotions that are not typically associated with math. So I think my why is closely related. It makes sense and it's enjoyable. And if we can make it feel that way, it will dramatically increase the amount of enjoyment that kids are having in school.
Yeah. Is that Berkeley? Did you grow up with a similar experience to Janene?
I was lucky enough to have a sort of an alternative curriculum that my teachers in high school were brave enough to try out, called CPM. So it was a lot of contextual work around, what does slope really represent, and how does math connect to the real world. So I think that's when I realized that math could be something else, but I didn't get back around to it until I started teaching, and that's when the whole world opened up to me of the possibilities.
I think it's so interesting, and thank you for sharing your stories. As we talk to people, it's almost like people can pinpoint these specific moments when something shifted. So both of you said a very specific moment, like you mentioned CPM, and Janene, you mentioned your professor making the statement about math is all about patterns and relationships. And that's amazing. Think about all the stuff that we filter out and we don't keep it in our brains because we can't, but we hold on to some things. So you used the word spark, and you talked about the emotion. There was almost like an emotional reaction that maybe we all long for, that connection happened, and it's like, I knew it. It is there. So it's pretty neat. We see this every time we talk to someone. There are these key moments that kind of carve out where we're headed in our relationship with mathematics.
Right.
Yes.
Yeah.
I think part. Oh, sorry. Go ahead.
No. Go ahead.
I was just going to say, and also thinking about just the access to how we are invited to participate, and what ways we're invited to participate. I think that a lot of times we hear that math is a barrier or math is a gatekeeper, and I really want to push back on that. And it's the practices, right? It's how we approach. What are the practices that exist that are barriers to all students having access and success and feeling the joy, and as teachers, what's our role what's our role in perpetuating and dismantling this narrative.
Giving everybody a seat at the table, right? By everyone, we mean everybody. A nice big round banquet table, right?
Yes.
Yeah.
Well, I think that plays really well in obviously why we're talking about this, but I think your focus has been a lot on this idea of fluency. And Janene, you were mentioning how you had your notebook where it was all filled in. And so, at that point, feeling like, okay, maybe I have this. And then, we have instances where kids did not have that was me, did not have the stickers in there. And so when you're looking at fluency and what that really means, I think sometimes fluency can have a really bad rap in the sense of how we teach it and how we approach it for students, and where, like, that was a traumatic experience for me as a student. And so, like, having that aspect of it versus for some other students, if they are good memorizers, or if they are able to grasp that maybe a little more quickly, they see that as like the only bit of mathematics that matters, versus all of that contextual understanding that is just so critical and so important. And which is why I really appreciated the work that both of you have been doing around this.
But Heidi, that's also it's making me think about what is fluency. Like, how do teachers define fluency? Because it depends on how a teacher defines it as to whether or not you are going to respond with love or hate. And that's different for all kids too. But I think when you're doing time tests and the time is the only thing that matters, there's a lot more opportunity for kids to dislike. I said hate before, but
Yep.
Yeah.
Janene, you want to share your slides? She has a couple. What pops up when you type it into the internet?
Yes. Yes. So
Molly, can you hide the banner so we can fill the screen?
Yeah.
I'm sure I'm just anticipating what we're going to see, because
So when you type what in the what is it that we,
math fact?
I went to Google. I was like, okay, gotta start somewhere. Google's the way. And so I just put it in, and I was surprised when I searched math facts, the sheer volume of just things that popped up in less than a second. So over 440 million, math facts. And I was struck by just how things were labeled, right? Memorize, fast, easy, 15,000 plus problems and puzzles. Like, what else do you notice?
I don't know. 15,000 was like insane to me.
Yeah. Well, and there's like the word monster in there, like in the purple box. I'm like, well, while I get that might be, exciting to some, maybe not so much in other cases.
Yeah, exactly. I was like, monster math, like there's some, or fact monster, meet the math facts. Like, do I really want to meet the math facts? Like, are they?
I don't know.
Do they talk back?
Yeah, I dug a little deeper, and I was like, okay, well, maybe there's what images might pop up. And so, I was struck again by, there's 35 foolproof ways to master fact fluency. I did not know if you guys knew that. But
oh God, I'm going to write it down.
Yes, 35 foolproof ways. And then there's 10 ways to drill it. And, it can be fun. So,
and that example looks really fun right there.
Yes. Yes.
So excited.
Well, like it's dancing, so obviously it's fun,
Right. And then I stumbled upon this, and there are appropriate ways that you can practice your math facts, and it involves a clock, I think. So you got to beat the clock, but at the end of the day, math facts matter. And I was like, do they? Do they matter? And for whom? And to what degree? And why? And what are all of those little teeny tiny things on those math worksheets? And if they matter, why are there so many on one page? So kind of just, this kind of got, I think, us thinking about, just how do we position math facts? How do we in our communities, in the classroom, in the world, in California, like what does this mean when we have this emphasis or this focus on math, facts, these static things that might be monsters. And
there you go.
so
Yeah, and I'll say from my personal experience, I didn't have 8 times 7 fully memorized or automatized until probably the last couple of years. And that didn't hold me back from anything in my life. I haven't been held back by not knowing that, not being able to recall that quickly. And now I have it both automatized, but I can also, if I forget what it is, I can quickly reconstruct it from a few different avenues. That even if there's a pressure, I'm not, I can't be stopped. I've got 8 ways to get there. And that flexibility allows it to connect to other things that aren't just 8 times 7. And in fact, we brought a little bit of math that we wanted to see if you wanted to do with us, and everybody at home as well wants to engage.
I mean, it is called the Math Together Show.
There we go.
So.
Let's do some math together.
And so this is a good opportunity for people to use that comment box, and that'll get you entered into the raffle too. So take it away. We're happy to play.
Fun.
All right. So there's a lot of things I could do. I could ask you, what do you notice and what do you wonder? But for today, I'm going to ask you how much or how many and how do you know? But take your time to think about it.
Are you going to call on us, or do you want us to talk?
No, go ahead. Go ahead.
I was just waiting. I was like, we're doing silent think time, which is so important. The wait time is critical.
I know.
So I'll start us out. I counted rows and columns. I counted the dimensions, and I hope I've counted correctly. I really wanted to touch the screen to be absolutely sure, but I didn't. So I think we have a 6x7 array here, and it's 42. That's what I got.
I did that also.
You did?
Yeah.
Molly, did you count 6 down first or the 7 across first? I'm just curious.
I did 7 across first.
Ooh.
I saw that it was uneven.
Interesting.
And
I counted down first.
I think I wanted to get that out of the way first.
Okay.
Well, I made an estimate first that the top row or the bottom, it is longer in that direction. And so then I was looking at groups of 4 on the top and 3 or on the bottom, either way. So broke it up that way. I don't love 7s.
I don't love 7s either. I kind of thought it was going to be, was Berkeley saying 8 times 7 before?
Right.
Oh yeah.
I thought it was going to be that, so I think that's why I counted the top first. Actually.
Sorry. Yeah.
Heidi, why don't you like 7s?
Ugh.
Well,
really?
I think they're the harder. Now as an adult, if I think flexibly about it as 5 and 2 or 2 and 5, that's much better. But to memorize those facts as a child, no, that did not happen at all.
No.
And so that was a big thing. But then, so I thought about it initially, and then I was like, well, but then there are halves. So is Berkeley asking me?
Oh.
Because I'm working on fractions with my kids at home right now, and we did this with oranges and orange slices, and so that came up. So then I went on a whole other brain tangent.
Tell us about that tangent.
So I was thinking about if I then had 6 times 7, could I think about it really as 3 and but then that makes it messy. 7 doesn't easily divide, and so then we were talking about the others, and so then I wasn't loving that piece of it. So Elena's saying now she sees the 21 holes. Yes, so it is that whole piece, but then I wouldn't want to turn that into a decimal right off. That didn't make it easier for me. So why would I do that? It would be easier to find the whole and then divide the whole by 2.
Yes, that's what I did, because I didn't originally. I was just counting pieces to start. I didn't even care that they were cut in half. But then as soon as you said it, because I knew 42, then I knew it was 21. But if I wanted to really, I could just kind of fold it in half.
Ooh,
Like
where?
that, I would fold it on the horizontally in the middle, so that then if you folded it, you could make holes, which means then you would have 3 times 7. I mean, that you can't really fold.
Oh, I
it
like
the
that
whole
better.
thing. I mean, obviously, in my mind, I can fold these and then they make perfect little kumquats. But
So are you saying like this goes with this one? Or
Yeah.
you were, yeah?
yeah,
Okay.
right, yeah, because the furthest ones would have to go with the furthest ones, right?
Yeah,
It's like a line of symmetry.
Right, right.
which is really important to Molly.
I really have some serious symmetry issues.
We've discussed this.
Yeah, it's come up on a few shows actually.
Mhm.
So Heather is saying 3 groups of 7 times 2.
3
Very
groups.
interesting.
Wait, Heather, come on now.
3
Let's see if we can find that.
groups,
Right, exactly.
3 groups of 7 groups of
Yeah.
2.
So like this way.
Oh, I see it.
I actually can't, the way my screen is, I can't see your gestures, so
Oh,
you're going to have to
sorry.
use your
So,
academic
okay.
vocabulary.
The first 2 rows, like so, grouping the rows together. So rows 1 and 2, rows 3 and 4, rows. Yes.
Yeah, nicely said.
Mhm.
Can you read me her statement again? Or I suppose I can go in and find it.
3
Yes.
groups of 7 times 2.
Oh my gosh, Heather, that's amazing.
There we go. Oh, hi, Heather.
Nice. So now I'm going to give us a blank screen. What other equations could match?
Wait, what?
What other equations could match this picture?
Okay. So
1 plus 1 plus 1 plus 1 dot 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 plus 1 equals 42.
Yeah, that's not very efficient.
Well,
It is one though. It is one.
The dot 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 was pretty efficient, I have to say.
Oh,
Yeah.
so 7 plus 7 plus 7 plus 7 plus 7 plus 7.
and 6 as well.
so we can think additively.
Right.
But something you had on Twitter a little while ago now makes me think about if we were to if we were doing this with multi-digit, right? We would automatically break it into 4 pieces, like in a way. So we could do that here as well if I liked, because I like 7 to be 5 and 2, and then I could have 3 and 3, or I could have 5 and 1. So I could break it up that way. So.
Oh.
Ooh, so it would be 5 and 2.
5 and 2.
And 3 and 3.
And 3 and 3. So
what would that
5
equation
times
be?
3 plus 5 times 3 again.
Again, yeah, right?
Yeah, and then
Oh, okay.
3 times 2 and 3 times 2. Or I could leave it as 6, which I think.
We have some distributive property in here.
Yeah.
Mhm.
That's fun.
How many equations are there? Is it infinite? Is there an end?
Ooh.
What do you think?
Well,
I think if
that's why we're asking.
I think it's finite if we deal with whole numbers, but there's lots.
So I asked a colleague earlier today, and she noticed a few different things, and she ended up saying this.
Mm-hmm.
Do you know do you know how she was grouping it in order to see it that way, or can you guess? I should say.
So she's saying 6 times 7 divided by 2 is 42. Am I to interpret it that way?
I'm guessing that she is saying that there are 6 rows with 7 in each, but they are halves. Is that right?
That is, yes, that is what she's thinking. How do you think that she visualized it? Because she visualized it first and then she gave this equation.
So we're getting the halves of the, are they tomatoes or kumquats? I'm not sure. Kumquats, okay. So 2 wholes, okay.
She didn't visualize it like this?
I'm curious, Berkeley. So it was 6 times 7 divided by 2 is the same as 42?
Mm-hmm. Oh, sorry. No, thank you. It was 21.
Okay.
Thank you. Sorry.
That's okay.
I was going to roll with it.
Yeah, sorry about that.
because I had questions.
Yeah.
But that's almost a thing, Janene, right? Because I was trying to make sense of the picture with what was there.
Mm-hmm.
And often teachers, when a kid writes 42, even because that's not correct. It's not the right answer. To 42 divided by 2 is not 42. But looking at that picture, I can absolutely see why somebody would write that.
Mm-hmm.
Right.
I have 42 halves, but mathematically it is not correct. But most of the time, teachers don't take the time to ask a kid what they mean by that. It's just marked wrong.
Yes. One of my favorite, one of my favorite mentors has always said, like, even in the stuff that may be wrong, there's lots of stuff that's right. So how do we focus in on the stuff that's right and go from there? Because, and I think it, connects nicely. Like, it's not an all or nothing binary thing, right? I think if we were to ask a kiddo, well, how do you know? Can you show me what you mean? We gain so much more insight into that.
Yep.
Yeah. So fun. So fun. Wow.
Yeah.
And so
thank you.
I'm wondering, when we start with pictures like that and we're working with students through how they're making sense of, and like thinking back to your main question, how might the math facts obscure what students really know? Using that, what might we see there?
Well, we won't know until we ask them, I guess, right? I think that's that is a big takeaway for me too. It's like when you're invited into a situation that has multiple entry points, whether that's a contextual story problem that is meaningful and interesting, not something about 2 trains leaving and, or, tons of granite being imported, which is a question I saw on a 6th grade exam recently. Just things that are, kids don't care about. If it's something interesting, if there's many ways to be correct or wrong in an interesting way, as Desmos talks about, that's when the real conversations happen. And that's when we go slow enough for kids to have unique and creative and interesting ideas that can be connected.
Well, and that whole time we were having that conversation, we were solidifying the fact that 6 times 7 is 42. Like that remained out there, for us to have all kinds of synapses and connections to that, and maybe something about 21 as well.
Yes.
So we're building long-term memory. So it's a really nice example of the contrast of how we can use some of the tools that you've really brilliantly put together and that you share on your websites. The stuff, Janene, that you pulled up when you Google it versus look what happens when we put up an image. And aren't we working on fluency? Aren't we working on 6 times 7 is 42? Right? And so maybe you would have known 7 times 8 is 56 a little bit more quickly with a whole 10 minutes spent on discussing an array of a 7 by 8 set of materials.
Exactly. And we have actually some student work, both
Nice.
an example where one student is the first grader of one of our colleagues, daughter of one of our colleagues, and she filled out a math worksheet that I made, single-digit addition problems, and then I also interviewed her as a follow-up to that, and we can kind of compare and contrast those experiences. So Janene, could you actually pull up the student work?
Yes.
Well, and I love that idea of making it visual and interesting.
Yeah.
As well.
Yeah. So now our question for you is like, what can we learn about Lucy from this? And it's not nothing. I'll start us off on a positive note. What can we learn about her?
She seems to, like all the friends of 10 are all there.
I mean, I'm noticing, because I actually have some personal experience with this, I'm noticing a lot of erasures, and in particular, the going over the 14 a lot.
11 too.
So I'm not sure what it indicates. It could indicate struggle, it could indicate frustration, or it could indicate, she's bored and she just keeps tracing over them. But there's a lot of erasures and going over, particularly those 14. So I feel like she potentially spent a lot of time to do this, but I don't know because I didn't observe it.
It's interesting that she knows two ways to get to 14, but the one that most kids will automatically know, she says, is 13.
The 7 plus
Right.
7.
Yeah.
Mm-hmm.
I mean, because kids typically love doubles, and so they typically know what their doubles facts are. That's interesting.
Yep. So this, so we can take this and we can think about what we can learn, which is based on eraser marks, or going over a little bit more, or correct or incorrect. And if I was forced to score that, or if it was 8 years ago when I was in the classroom, I would have given it a score, and it would have been probably on correct or incorrect. Although also we gave this to her without a time crunch. I think that could have added other incorrect answers, or also stress, unneeded stress on her. So I probably would have scored it a 9 out of 10 in the past, but really I feel like anytime we score something, all we do is focus on the gap, that 10% that she got wrong, right? Or as Dr. Gutierrez talks about, we're skilled gap gazers. So that's we're always focused on what they don't know, and it's so much easier. And Janene and I, when we're working together, it's so much easier. We find, and the work of cognitively guided instruction says, build on what kids do know. It's so much easier to build on what you already know.
I think I read something about become a strength finder. Get out that look for
now more than ever we need to do it, right? That should be everybody's summer work.
Yes.
Yeah.
Especially I'm sorry, go ahead.
No, go ahead.
Oh, I was going to say, as we, in California, we're going back into classrooms, and at least in, LA Unified in a couple of weeks. And, I think it is focusing on the strengths, as opposed to, the narrative that's out there of learning loss. It's not about learning loss. There is no learning loss. There have been so many learnings that have been gained by our kids, and how do we rethink school so that we can really begin to understand all of the incredible things our kids bring to the classroom, and if we position it in that way, how will that help us to change the world and change the narrative?
That's right.
I feel like that's a thread that just keeps coming back in our shows, no matter what our topic is. That seems to be the common thread that turns up every time.
Well, I think we're all in positions where we can push back on this narrative that is out there. And, it's very frightening as a parent, as, someone who has a lot of kids in her community. So you do worry in the back of your mind, is my kid okay? Are they keeping up with whatever keeping up means in a given time? And, are they also safe and happy, and, in environments where that can continue? But it is easy particularly I think in education for too long, we've looked at like the gap or what kids can't, and we have to continually push back on where the strengths are, and it's our job as adults to be the one who adjusts to that, right? I think, it is, so if we have children who have learned at home that they need to be up and moving around more than is comfortable for us as adults, like, so maybe we need to design school spaces that allow for that. And there's lots of thoughts that we
have a lot of power. We have a lot of power, right?
Yeah.
Would you like to see what Lucy does now?
Yeah.
Yeah.
Of course.
All right, here's a short video of me talking with her. You might call it teaching, but I think I do more asking than teaching. Here we go. Oh, there we go. This goes with that 7. Can you hear it? And that goes with that 7? Good. Oh, got it. Okay. So if you know that 7 chicken nuggets plus 7 chicken nuggets is 14 chicken nuggets, how much would 7 chicken nuggets plus 8 chicken nuggets be?
15.
15 chicken nuggets? How do you know?
Because it's 1 more than 14.
What's 1 more than 14?
15.
How did you know it needed? Oh yeah, go ahead.
And 8 is 1 more than 7.
Nice.
So this 8 is 1 more than this 7?
Yes.
What other problems do you think would be easy for you to think about because you already figured these out?
Maybe 7 plus 9.
Yes.
What would that be?
Yay, Lucy.
It would be 17.
How do you know it's 17?
I used my fingers.
And she went on to explain that she counted 8 and then 2 more, but then she started to lose a little energy, which I totally understand. It was the end of the day, a lot of Zoom. So we just stopped right there because I think something I'm learning from the incredible teachers in Los Angeles who I get to visit is just if it's okay to end a lesson and come back to it the next day, sleep on it.
Yeah, that's a hard lesson to learn. I think that takes a lot of years to be able to just stop. Teachers seemed, and especially, I want to say I was a middle school teacher, and there is a bell that rings at the end of class. And so you have to get everything done by the bell. So there's an actual physical pressure. So that's a hard thing to learn, I think, for secondary teachers.
Yeah. That's not how learning works, right?
Oh, it is not.
So what did you learn about Lucy that you wouldn't have known otherwise? Or what did you notice about her thinking?
With the second problem as opposed to the page of problems. Well, context, I think, really helped her.
Yeah, she was 7 times 7 plus 7. Yeah. She
pretty quickly, and then Molly, she pretty quickly used that to determine 15. And I don't know if that would have happened without the context, because there's this thing that we do where we imagine, well, I just got 1 more chicken nugget. That's what, but it's
so obvious.
Oh my God.
So it's 1 more, and right. But if I wasn't picturing Mom sticking 1 more nugget on my plate, and it was just how does 7 plus 8 relate to 7 plus 7? I'm not sure. So it seems as if she engaged with the context really nicely, and then she wanted to go down the road of generalization. That was a really nice question. What else could it help you know? She wanted to go there, and then she wanted to jump to 10, which is where I thought. And so she, I think context matters tremendously, and it builds on that that visual memory. Different than the picture of the array, we're using language to conjure up an image, or she drew them. Those might have been chicken nuggets.
Yep.
Yeah,
Right.
or a representation of, and I think, that problem is really nice too, in the sense that we can think about it. You went up 2, but what if we were to take 1 away? So what if little brother or sister ate, or mom or dad ate one of your chicken nuggets? So in that sense, so that you have 7 and 6. So I think that's a tricky addition problem sometimes as well. On either side of 7, that doubles fact can be a real challenge. And
Well, let's face it, we're adults and we don't like 7.
Yeah.
I mean,
already admitted that.
Yeah, you did, and I don't like 7 that much either.
Oh, I love 7.
Well, of course you
lucky
do.
number.
No, not for me. I like even numbers.
Most frequent dice roll. You roll the dice, you're likely to get a 7.
But I know, Heidi, you mentioned that you like 5 and 2. But if you like 5 and 2, does that mean you can't like 7?
I mean, I think I really don't like 7 at all.
Janene, you are not going to convince her.
I don't like it. When I actually think, I say it initially as a joke, but when I think about like the 7 stacks in their entirety, I don't like it. And then I actually like even adding 7s, adding and subtracting within 7, like it's not as easily manipulated. So I like 5 and 2,
True.
but then what if I needed to break it into 3 and 4, and that's more messy, and like it just
7 has traumatized her. That is clear.
Yes. So I will not ask Heidi to memorize her 7s. No math facts for 7s.
And so far she's been fine.
But you don't. Isn't that the point though? Right?
Yeah.
Like, there are not 100 facts that you need to know. There's a lot of important mathematical relationships, and you don't have to solve any problems with 7 if you know how to break it up and put it back together in a different way.
Right.
And if you're given the chance to.
Yes.
Right.
Yes.
Because that was an adult learning. That was not a kid learning.
Right.
Yeah.
And like even when Lucy was adding there, so somewhere along the way, as a kid, I remember realizing that any number plus 9 was that other number, 1 less than that other number in the teens. But like,
Can you say that again?
So when she had 7 plus 9,
yes,
so I know it's going to be 10 because it's going to be over, but that it's going to be 1 less than 7, which is actually not very efficient. But like I figured that out as a kid, like so I'll do that even
But
now.
it's
And
fast. It is fast.
It is, but like it would have been faster if I were breaking up that other number and giving 1 to 9.
But it all depends on the person.
9 and then less than the other one.
Right. I see what you mean, but I think it's totally dependent on the person. We got to give everybody a chance to do it the way that makes the most sense to them.
Yes.
And you're strategic in your thinking
Yes.
for you. And you're working with, you're decomposing and working with some beautiful mathematical properties that if we ask our kiddos, just know your 7s, just know your facts, we put up a barrier to them having access to the thinking that's important and the relationships and the patterns that exist that help us make sense of math.
Right, which many of us learned as adults.
Yes.
And we did just fine until then, right?
Well, that's the argument, right? Why do we have to do all of this? Because we're fine. I mean, if we take Heidi's testimony of 7, we're not all fine.
I just meant that we didn't need to have all of those facts recalled in order to be successful adults. Right. And if we're going to have our kids learn their facts, let's do it in a fun and relational way that's slow and not stressful.
Right.
And that way we actually bring those relationships a lot in those patterns that you were talking about at the very beginning, Janene, a lot longer. Like
Mhm.
that's what will stick with us. And when people are so concerned about, kids in math, I want my kids to do well in math, so I make them flashcards and have them memorize,
Right.
versus building on that relationship and pattern making, which is harder. It's a lot harder to do, but sometimes I think as parents we short circuit that. I've definitely had conversations with my friends about, like, can we not do that?
Mhm.
Like, let them, like, I know you think the teacher's taking too long, but let them do what they're doing, because in the end, like, they're really teaching your child to look at number flexibly and to think about those relationships versus just doing something so quick.
Yeah. I feel like this leads into this question, right? So how
Yes.
can we learn, or how can our listeners learn more from you?
Yes, so I have a website where I'm sharing my current understandings, which are not perfect and not complete, and that's okay. But you can follow my journey there. And Janene?
Excellent.
Yes. And you can follow me on Twitter. I'm a great retweeter. So, I think that, and maybe if you're not like into the virtual world, like, find a great book and read it that really you love and brings you joy. And I think that's a great way to kind of learn more apart but together.
Oh, yes.
So important.
Right.
So, that you both have so much to offer, and you're being modest here in this section of where can we learn more. So there's so much there, and I spent a lot of time today pouring through the resources and actually having so much joy and so much fun, and I just seeing all the things and all the work that you're doing. So I encourage everybody to please go and check those things out. We'll post those links in the comments, so you'll be able to readily click on them. And yeah, tell us about this here.
Okay, so Berkeley and I are housed at UCLA in the School of Education and Information Studies, in the Math Project. So Math Project is part of Center X, and we are a statewide project that focuses on mathematics professional development for teachers, and working with students, and issues of equity and social justice. And we both currently work with LA Unified in its CGI Action Research Project, which has just been an amazing opportunity for us to be in spaces with incredible teachers and administrators and students to really, study student thinking and the practices that make spaces for student thinking to be at the center of our instruction and our work. So you can find more information at CenterX on the link that was shared.
Excellent.
Yes.
Excellent.
Yes.
Well, we are so thrilled to have had the opportunity to talk with you guys tonight. This was so fun. I love kumquats now.
It's not really an East Coast thing.
It really isn't.
Not at all.
No, I don't.
Like,
know
I'm pretty
where
sure I've
I
never
could
had
get
one. Yeah.
No, I don't think so.
Well,
No.
I'll bring
You can eat the
one
whole
to you when
thing,
I see you
right?
at the math conference.
That's
Yes.
right.
There you
That's
go.
right. Excellent.
Yes.
Excellent.
Well, and thank you for all that you do. You make a tremendous difference in the lives of children, which is what it's all about. And we appreciate all the hard work that you're doing. And we thank you for spending a little bit of time with us tonight.
Of course. Thank you so much
you.
for
All
inviting
right.
us.
Thank you.
All right.
Yes.
Take good care. Be well.
Thank you.
Excellent. So let's not forget about the raffle. Go ahead,
Yeah.
Molly.
Yeah, no. That was so fun. I love it when we actually do math. I love all the shows, but I love it when we actually do some math. It's so fun.
Mm-hmm.
All right. So where are we now? What were you going to say?
So the
Sue?
raffle is a mini course. And so if you've been in the comments, you'll be entered into that. But even if you're not watching live, you can go ahead and enter. And so we will choose a winner by 7 p.m. Eastern Standard Time on Monday. And we'll contact you if you're a winner. And there's 2 winners. And so certainly drop something in the comments
Yeah.
And we'll look at Twitter, Facebook,
Yes.
and the Looney Math YouTube site where these recordings are housed afterwards. So if you are not watching on Facebook, that's okay. You can comment on Twitter or you can comment on YouTube.
Excellent. And if you want to do more with us, we would love to walk this journey with you as well. You can easily hop on that mailing list with the text, and you can learn more about what we do, which is to support students and teachers in making joyful, powerful experiences for all learners at the Looney Math website. Thank you so much for being with us this evening, everybody.
Hold on.
Oh,
Yeah.
Yes, we gotta do next week.
yes.
So next week on March 31st, we are going to be talking to Jenna Labe, and she is famous for her slow reveal graphs, and I am super excited to talk to
Yes.
her.
We're going to be talking about
Absolutely.
data literacy.
Yes, I was
Yes.
totally playing with them today, so I'm so excited about it. So thank you so much for being here, and remember to always be curious.
Good night, everyone.
Hey,
Bye-bye.
good night. Take good care, everybody.